Hey guys, this is 6.3, just some notes about the conceptual stuff we're working with. There's some really basic stuff towards the beginning that I think for the most part you guys understand. That, if you take f of x and you add g of x to it, that's, if f of x was, if it was 3x minus 5 and g of x was 8x plus 2, that would literally mean take 3x minus 5 and add 8x plus 2 to get 11x minus 3. So conceptually, I think the beginning of the assignment is really just about, hey, remember all of our different rules for adding, subtracting, multiplying, and dividing equations. But where we really get into the meat of the assignment and the meat of the content is when we start to talk about compositions. So I'm going to take a couple of example problems or a couple of example functions. Let's write 3 of them down. Let's say f of x is 2x minus 1. Let's call g of x. You know what, I'm going to change colors on this. I think we really want to make sure things are really clear. So we're going to do g of x in green. G of x is maybe x squared plus 3. And then let's call h of x 5x minus 2. So we have these 3 functions, and we want to do a couple of different things with them. They're what's called a composition, okay? And a composition is a building of a new function. The way we build these functions is by embedding one function inside of another and doing that kind of calculation. So the first thing I want to look at, let's take a look at f of g of 3. Okay? So I'm going to give you a number here. This is what I call type 1 because we have a number. If that's ever an x, the problem is slightly different. But this is only going to work for when x is 3. So this is it's great because it's a little simpler to understand conceptually, but it has its downfall in that this works one time. If I want x to be 5, I'm going to have to recalculate. So the basic premise is that, g of x, I got to get green, dang it, g of x being x squared plus 3, okay, if I want g of 3, right, think about that, this says g of 3, the only way I'm going to get g of 3 is to take the x and let it become 3. That would be 3 squared plus 3. You can see how the 3 has taken the position of the x in my g equation. So now I have g of 3 is equal to 3 squared would be 9 plus 3 would be 12. Now this right here is really, really important. The g of 3 and 12 are the same thing. They are equal to one another. So when I come back up to this idea of f of g of 3, right? F of g of 3. We can remember from what we just figured out that g of 3, right here, is the same thing as 12, which means that this thing is equal to f, not of g of 3, but of 12. I'm taking that g of 3 out, and I'm putting in its place the thing that it is equal to. Well, that's nice because if f of x is 2x minus 1, then the only way I'm going to get f of 12 is to let x become 12. So over here, the x is going to become 12 minus 1. Well, 2 times 12 is 24, minus 1 is 23. So we can claim that f of g of 3 equals 23. The way I actually like to put the notation together is this, that if we take 3 and put it into equation g, we get 12, and then we take that answer 12 and we put it into equation f, always substituting for x. It's like a double substitution. So there's type 1 composition when we have a number in the place of x. But what happens when we don't have it? The reality is f of g of x, or f of g of 3 is great, but it only gave me one answer. I'd really like to have something that gives me every answer so that I could plug 7 in and get the answer. I could plug 2 in and get the answer. I want to be able to do something that fixes all of the problems. So let's take a look at a composition in our second variety. All right. So our second type is when there isn't a number, but instead we have a variable. So let's try to do, let me grab a different color. Let's try to do h of f of x. So you notice, okay, that right down here, that's not a number. That is a variable, which means I can't put the x into f, get a number, and plug that into h. When this is the case, we have to recognize that we don't have any way to replace f of x with a number, but we can replace f of x with an equation. So what that means is, over here when I write h of f of x, instead of writing f of x, I'm going to write what f of x is equal to, 2x minus 1. So if you look right here, right, if you think about it, h of x equals 5x minus 2. The only way I'm going to get h of 2x minus 1 is for this entire thing to replace the x. So h of 2x minus 1 would equal 5. And instead of putting that x there, I have to have it match this 2x minus 1. And of course we have our minus 2. Look at this pattern over here. Does 5x minus 2 still look like 5 times something minus 2? The structure should look the same. Now all I have to do is distribute and clean it up. This would become 10x minus 5 minus 2, or 10x minus 7. And that would be our simplification. Hopefully this idea of burying one function inside of another will be something that becomes a little bit more clear as you practice it and work on it. But good luck, and we'll see you in class.